Dear students, in part 1, we have seen how to draw the project network diagram using activities and precedence relationships among the activities. In part 2, we have seen critical path method, finding project completion time, total float and free float for all the non-critical activities. For critical activities, total float and free float will be 0. In part 3, we have seen PERT, performance evaluation and review technique. In that, we have found the expected project duration and also probability of completing a project in a given period of time. Now in part 4, we will see project crashing. It is nothing but reducing the project duration. How will we do it? We will do it by reducing the time of one or more critical activities to less than the normal time. Please note that whatever activities there are in the critical path, we will try to reduce the duration of these activities. We will see it with a case study here. This table shows the activities using events or nodes. Activity 1, 2 is represented by node 1 and node 2. Node 1 is the starting node, node 2 is the ending node for this activity 1, 2. Similarly, for activity 3, 6, starting event or starting node is 3, ending event or ending node is 6. The question is, if indirect cost is rupees 200 per day, find the optimal crashed project completion time. Please note that we have to balance this indirect cost with the crash cost, because if we save the project duration by 1 day, we are saving rupees 200, but reduction of 1 day increases the crash cost depending upon which activity we are crashing. So we have to find out the balance between crash cost and indirect cost, increase in crash cost with the decrease in indirect cost. For that, we have to find out the cost slope for all the activities. Normal time and normal cost are given, crash time and crash cost are given. With this data, we can find the cost slope. We will take activity 1, 2. Normal time is given, crash time is given. So the difference is 7 minus 4, 3 is the denominator here. Crash cost minus normal cost is 150, which is the numerator. So the slope is 50, I have filled in here. What does this slope indicate? It indicates that if I reduce the activity duration by 1 day, I will have to incur a crash cost of 50 rupees. Right? This is what indicates. Now for all the activities, I have found out the cost slope. We will verify for one more activity here. For activity 3, 6, we can see that normal time difference is 6 minus 5, 1. And crash cost minus normal cost is 200, 1300 minus 1100 is 200. So 200 by 1 is 200, it's okay. Now, normal project completion time is 18 days, that we can see it from the network diagram. We will see it in the next slide. Total project cost will be the addition of indirect cost and the total activity cost. Total activity cost is the sum of all the normal cost for the normal time period. This is the total time for this activity and total normal cost for this activity. So similarly, for all the activities, total activity cost is given. So total of all these things will give you the total activity cost for the project. Now, we will see the network diagram. Network diagram is drawn based on activity, precedence relationships, and the normal time durations, which are written here, say 7 for activity 1, 2. Likewise, you can verify for all the activities, the durations are mentioned correctly or not. Now, we have to fill in the earliest starting time and latest completion time for all the events. For earliest starting time, we'll have to start from the tail event, that is starting event. So I'll take 0 here and I'm filling it up for all the events here. Please note that 0 plus 5 is 5, 5 plus 6 is 11 here, whereas 0 plus 8 is 8 here, 8 plus 7 is 15 here. So I have to take the maximum of 11 and 15, I have taken this 15. Similarly, for node 5 also, the 7 plus 9 is 16 and 5 plus 5 is 10. So maximum 16 I have taken. Similarly, I have to find out the latest completion time for all the events starting from the head event. That is 18 I have started. So 18 minus 2 is 16, 16 minus 9 is 7. Here 18 minus 3 is 15. Now when it comes to this node 3, 16 minus 5 is 11 and 15 minus 6 is 9. I have to take the lowest value. For latest completion time, I have to take the lowest value. For the earliest completion starting time, I have to take the maximum value. So with this rule, I have filled up all the E and L values. Now critical paths are obtained by using the relation for any activity, the end node E and L and starting node E and L the starting node E and L should be same. Ending node EL and L should be same. E and L 16 here. E and L are 7 here. The difference between 16 and 7 is 9 activity duration. So this is the rule for the critical path. I will mark the red arrows for the critical path 1 and dark brown arrows for critical path 2. So you can check up this for the ending node and starting node for all the activities, the conditions. Right. So here, if you see here, 15, 15 and 8, 8, the difference between 15 and 8 is project activity duration. Now we know the duration is 18 days for all the different paths I have calculated. For example, 1357 activities, 13 activity 5 days, 35 activity 5 days, 57 activity 2 days. Total is 12 days. Critical paths are 18 days here, these two critical paths. Now, total cost for normal duration is total activity cost, which we have seen 6,500 plus indirect cost for 18 days at 200 rupees per day is 3,600. Total is 10,100. Now, there are two critical paths we showed. So the least cost slope is for activity 1-2 in critical path 1 and least cost slope is 125 for activity 4-6 in critical path 2. Therefore, we can crash these two activities simultaneously first. Now, this 1-2 activity can be crashed by 3 days, whereas this can be crashed only by 2 days. Therefore, I'll crash both by 2 days first. Now, crash 1, I'm reducing by 2 days activity 1-2. I'm reducing activity 4-6 by 2 days. Now, total duration has reduced to 16 days because I reduced activity time for activity 1-2 is 7 to 5. Similarly, activity time for activity 4-6 is 7 to 5, right? So by 2 days I have reduced. So total duration is 16. Now, project completion time after crash is 16 days. From 18, it is 16. Now, total cost is 10,100 is the previous total cost. Plus crash cost for 2 days is crash cost per day is 50 here, 125 here. So 50 plus 125 per day for 2 days, 2 into 50 plus 125. Minus 2 days saved, therefore indirect cost is saved for 2 days at 200 rupees per day. So if I put it, I'll get 10,050. 10,050 is less than 10,100, which was the previous total cost. Therefore, we have crashed the activities, we have crashed the project duration. Project duration has come down to 16 days and the total cost also has come down. So this is what everyone would like it. We will try to continue crashing now. See, after crash 1, this network diagram is shown like here. So 16 is the total duration. Previously it was 18. This is because I reduced the activity duration from 7 to 5 here and from 7 to 5 here also for activity 4-6. Now what we will do is, there are two critical paths, 1257 and 1467 now. So we cannot reduce activity 4-6 any further because we have crashed to the maximum extent. Only 0 days are available. Whereas 1-2 we can crash further by 1 day. Now the next least cost slope is 200 for activity 1-4. Therefore, I will crash activity 1-2 and 1-4 by 1 day now. Right now, this crash cost is 50 plus 200 is 250, which is greater than the saving in indirect cost, which is 200 rupees for 1 day. So we'll have to say that crashing incurs cost, therefore cost has increased because crash cost is 250, whereas saving in indirect cost is only 200. So we see it is 10,100. We will have to check up with the management whether it is acceptable or not. But please note that we started with 10,100 for 18 days. Now we are ending up with the same cost. Therefore, we are able to crash the project duration without incurring any additional cost. So this is what we are recommending. But what management may say is, no, we don't mind 15 days at 10,100 rupees. So we are not incurring any additional cost, but we are saving. No, delivery schedule is more important. We must maintain the promised delivery schedule. So crash further. So I want to crash further. Then please see that 1-2 cannot be crashed any further. So I crash 5-7 from critical path 1 and activity 1-4 from critical path 2. The crash cost is 100 rupees for 5-7 activity and 200 rupees for activity 1-4, which you can check up from the data table. So 300 rupees for 1 day reduction and the saving is 200 rupees indirect cost for 1 day reduction. So net increase is 100 rupees. Therefore, it has come down to 10,200 for 14 days. And I can still further crash by 5.7 cannot be crashed any further. Therefore, I crash 2.5 activity. The cost is 225, and I can crash 1.4 activity further by 1 day. It is 200 rupees, which you can see it here. So 225 plus 200 is 425 is the increase in cost. 200 is the saving in indirect cost. Therefore, net increase is 225. Therefore, total project cost is 10,425 and project duration is crashed to 13 days. So management can make any decision. If it is possible, please note we'll have to check up also whether it is feasible. Right? Practically, if it is not feasible, theoretically it may be possible, but practically it may not be feasible. Then we cannot crash. See, for example, I'll tell you that painting is to be done. 4 walls are to be painted. So one painter and one helper is engaged. So this painter helper team can take 4 days to complete the painting. Now theoretically I can say that I can put 4 teams, 4 painters and 4 helpers, so that in 1 day the painting can be completed. But practically it may not be possible, because in one room if I put 4 painters and 4 laborers, they will only chit chat. They will sit on one on top of the other, and there will be no productivity. It will not be completed in 1 day. Therefore, the management will have to take all these into considerations and make a decision whether we go ahead with the crashing or cost saving or any other decision, right? So crash till no loss, no gain is reached. That also is possible. We will take one more case study here. Activities are given in alphabets. Activity durations are given using events or nodes. Activity 1, 2 is represented by node 1 and node 2. Node 1 is the starting node. Node 2 is the ending node. The normal cost and normal duration are given. Crash duration and crash cost are also given. Cost slope is found out as usual. We know sample calculations are given here for activity B. See, 200 minus 100 is 100 and 8 minus 6 is 2. Therefore, slope is 50 here for this activity B. Indirect cost is given as rupees 70 per day. So this is very important. This is what we are going to balance with the crash cost per day. Please note the network diagram is drawn here. We'll take further. See, A is 2 days and crashing possible is 1 day. Here crashing possible is 2 days. Here crashing possible is 5 days. Right? This is a critical path as given in the table. 20 days is the total durations. So total cost is total cost of activity, which is 730 plus 20 days we have found out, no. Therefore 20 into 70 per day indirect cost. So 1400 plus 730 is 2130 is the total project cost for normal duration. The activity and activity duration, normal duration and crash duration was given here. This is nothing but the difference between normal duration and crash duration. So 2 days I can crash. Now, first crash one is I'm crashing this activity A by 1 day, because we can reduce only by 1 day, and activity B by 2 days. We can reduce only by 2 days. Please note these activities are in series. Therefore, I can save 3 days. I can reduce the project duration by 3 days. So total cost after crash will be, so previous cost is 2130 plus crash cost involved for crashing activity A by 1 day is 50 rupees. Crash cost for crashing activity B by 2 days is 2 into 50, 100 rupees. So total crash cost is 150. Whereas I'm saving 70 rupees per day for 3 days, reduction in duration. Therefore, the net answer is 2070, which is lower than the previous cost 2130. Therefore, this is very well acceptable. Now, total duration is 17 days and total cost is 2070. We will see here activity duration and crash duration are given. I have drawn this, the revised network diagram. So activity duration is 1. There is no scope for crashing. Here also there is no scope for crashing, but there is a scope for crashing up to 5 days, right? So total cost after crash 1 previously, we have already seen this. Now what we will do is, we will see for this activity 3.6 is going to be crashed. How many days? So I said 5 days is possible, but crash 2, I am saying only 4 days I'm going to crash. Why not 5 days? Right? Why only 4 days? Please note that if I crash it by 4 days, right, that is 10 to 6, the total duration comes out to 13, and the total duration for this path also is 13. That means there are two critical paths. Therefore, if I have to reduce it by one more day, then I have to reduce any one of these activities in this critical path also by one more day. Therefore, I cannot reduce this alone by one further day, right? Therefore, now 4 days I can reduce this activity alone. Therefore, I am reducing it by 4 days. Uh, Now we are getting two critical paths. So further reduction is possible only if I consider another critical path also, right? Therefore, two activities I'll have to crash further. Therefore, 1, 2, 4, 5, 6 also needs a reduction if I have to reduce by the fifth day. Okay? So total duration is now 13 days. You can see these two critical paths are there. 1, 4, 5, 3 also becomes critical path now. Right? Total cost after crash is 2070 plus 4 times. This is 60 rupees per day crash cost. Therefore, total crash cost after 3 is 2030 plus, one second, here I would 2070 plus 4 times 60 minus 4 times 70 because indirect cost saved for 4 days. This is 2030 is the crash cost for 13 days. Now I'm doing the further crash 3. So where I am doing it uh, for F as well as activity G. Please note that here I have shown the crash cost for these activities C, E, and G. Activity C is nothing but 2, 4. We'll see 2, 4 here. 100 rupees crash cost, and 4, 5 is 50 rupees, and 5, 6 is 10 rupees. Therefore, I have to consider the least cost slope, which is activity G. So I will reduce activity F by 1 day and activity G by 1 day. Then we will see that what is a crash cost. For 3, 6 activity, I have to spend 60 rupees. For 5, 6 activity, for crashing by 1 day, I have to spend 10 rupees as a crash cost. So total crash cost is 70 rupees. Whereas I'm saving 70 rupees in indirect cost because of duration is reduced by 1 day. Okay, project duration is reduced by 1 day. Therefore, saving in indirect cost is 70 rupees. Both are same. So the cost remains same, right? For the same project cost, 2030, right? Say 2030, before also 2030, now also 2030, we can reduce the project duration to 12 days. Now this extra effort is required or not is a management decision. Sometimes management may say that if you do it in a hurry, if you try to reduce the duration, quality may suffer. Or you might have promised a delivery schedule at the start of the contract that I'll finish it in 12 days. Then you'll have to go for this crashing. So depending upon the situation, management may take any decision, whereas I've given theoretically what are the possible values. This is normal duration, 2130 is a cost. For 3 days reduction, there is a reduction in cost, 2070, and I can still reduce 2030. And if I reduce further, there won't be any gain or loss. Right? Therefore, beyond this, if you want to crash, we can do further. Probably as a homework, we can do it. Right? But it is not possible here because we have 1, 2, 3, 6 has reached. There is no crashing further possible in critical path 1, 2, 3, 6. Okay, that is 13 days. So crash cost minus indirect cost is shown here. How this cost is arrived at. You see. So management will have to take a decision based on this. Now, what is the objective we have seen so far? To finish the project early and know what should be the additional cost and what could be the maximum duration saved. That is the management position. Can we finish the project early? Because we have promised a delivery schedule. If so, what should be the additional cost? Suppose I want to reduce, crash the project duration. What should I spend? What is the additional cost? Then I'll take a decision. And what is the maximum duration that I can save so that I can talk to the customer and say that beyond that it is not possible. So negotiation is on the card. So management considerations in crashing are many factors. Many factors need to be considered. Saving is not the only criteria. Delivery schedule also is the criteria. Sometimes maximum number of days that could be crashed may need, right? And sometimes we may say that additional cost for crashing further. What is the maximum number of days we can crash and what is the cost that I have to incur for this? Then practically feasible or not, that also I'll have to see from the project people. And even if theoretically possible, but not practically feasible, we cannot do crashing. Therefore, crashing has limitations. There is an objective that we need to deliver it on time. That is a goal. In order to deliver it on time, we'll have to monitor the project progress. So when we go on monitoring the project progress, if there is a delay, then we'll have to start doing the crashing. At the time of crashing, we will have to see the additional costs incurred as well as the delivery schedule to be maintained. These are all the things you will have to remember while doing crashing. I think I have completed the CPM and PERT in part 4 also. All the four parts, please view again so that you can understand. And if you like it, recommend to your friends also. Thank you very much for watching. I'll stop recording. Right? If you like it, please subscribe to my channel also so that you can get more videos, free videos on education.